Welcome to another Great Cow Basic tutorial. Today we're looking at the Logic Green Technologies LGT8XM, and today we're specifically looking at SPI, or Serial Peripheral Interface. SPI interfaces. So we're getting to the end of the tutorials to show you the capabilities of this chip within the context of Great Cow Basic. And tomorrow we're looking at the tool chain, just to give you a quick insight into the tool chain. So these are the types of boards you can procure. I've been using the Uno type by the Nano board, the green one on the top left. But today I'm actually going to be using an Uno style board. It's not an Uno because it's not an Atmel chip in the middle, it's an LGT chip. I built myself a little shield that plugs into this to help me with the connectivity. So what do all the connections look like? They look like this, and I'm going to be using a series of connections to use the hardware SPI on the right hand side. And I'm going to be using this bank of connections here, and I'll just zoom in on those so that we can have a quick look at the serial peripheral interface connections, or SPI. Now, SPI requires us to have a clock line, if you look in the blue, and I'm going to map that into the SCK line. Data in, I'm going to map to the MISO, which is master in, slave out. Our device that we're going to be using is a slave. I'm going to be mapping the data out to the master out, slave in. And the last one that I need to do is chip select, and then that will tell me that I'm using a particular device. And with SPI, I can have multiple devices on the bus, and how I select those is via the SS or chip select line, so it knows exactly which one to be using. Now, for this particular display, I also need a reset line, and I need a data control line, and I'm using these. Now, these bank here of 13, port 13 down to 8, are regularly used by shields that plug into an Uno. So I've used exactly the same ones because I know that the clock, the master out, slave in, and the chip select line, or SS, are all on those ports 10 to 13. Okay. So let's have a quick look at what SPI is all about. Once I've got essentially 4 pieces of that I'm going to control in an SPI protocol. I'm going to be doing the chip select or slave select. It's going to be high or low, and when it goes low, I can then clock my data out on the clock line, and depending upon the state of the data line of the master out, slave in, or the master in, slave out, depending on if it's high or low, I will then know I will be sending a 1 or a 0 bit, and will receiving a 1 or 0 bit. And so in this particular case, if I do some quick maths here, that is 4. If I look at the nibbles here, that is 4. Let me just look here. That is 1 nibble is here. That is 4 hex, and that is 6 hex, so I'm sending 46 in hexadecimal, and where the lines are, where it's clocked out, the devices will know to read 46. Now, in reality, a real implementation of SPI does require additional lines, and this is actually from the data sheet, and it essentially says I have a chip select line, which is the SS as well. When it goes low, I can send data commands, I can send master out commands, and I can send the data packets. And I need to control all of these lines in a sequence, including the reset, and all that is done within the library. But essentially, we have low-level SPI commands that are simplified within Great Cow Basic. Let's have a look at what we're going to be doing. We're going to be using an LGT Uno board. I put it in italics because it's not really an Uno board, but it's similar. And we're going to integrate that a GLCD. And I'm using a particular type of device, an ILI 9341, and it has a particular pixel size. We're going to look at the setup. We're going to look at how we just add some text to that, but we are using SPI and we're focusing on SPI. And then we're going to use show some sprites. And what's important about using the sprites is I can show you the speed difference of hardware SPI versus software SPI. So let's have a look at what I've got in the lab. I've got some sprites bouncing around. Now, it's dark in the lab today because the contrast is pretty low. Look, there you go. If I start to turn the lights on, that's not fully on, I can tell you. That's only one lamp on. I'm having to do that purely because of the contrast. And underneath here, where my marker, my pen is now, you can see there is the edge of a PCB, which is the Uno, and then there is a shield board I built here to connect in through the connections on the graphics device. And underneath there, trust me, there is an Uno type board. So let's have a look at some code here, shall we? Let's get directly into the code. Let's get into the meat of this to see how it actually works. Well, as normal, we've got the chip type and the option explicit, so that we must define our variables. I am going to join together a number of these items to keep it nice and simple. Well, I've got a GLCD library included, and then I'm going to tell it the type that I'm using. We've seen that before. And in this particular one, I'm using an ILI type, GLCD type ILI 9341. And there's many that you could be using. I'm telling it to use hardware SPI, and I'm telling it to use the ultra-fast mode. Those are a number of constants that you define. If you comment these out, it will go direct to software. And then a series of constants just to set up these different lines. And these different lines are, you've heard me mention these, a data command line, a reset line, chip select line, data out line, data in line, or a clock line, SCK line. And once they're done, then you can use simple code, the GLCD commands to make it work, because the complexity of SPI is masked. You can send low level. There are low level SPI commands like SPI transfer. There we go, SPI transfer. Send out you could send out a number, and you could receive back a value in I'll call it in data. But we've masked that because the low level stuff still uses these same control lines in terms of DC, reset, chip select, data out, data in, and SCK. And so the smart eyes, or the smart people will have noticed I've used other constants here, digital 8 to digital 13 to relate to this Uno type board. And I've been able to do that because I've included this .h file here for this particular chip. Let's compile that up and see what that actually has, what the impact is out on the lab. It's compiling it up. It's just about to load it in now. Well, my camera is upside down. This is spectacular. Oh, it's not. Oh, it's the way I've connected my camera. I'm very sorry. So the camera is flipped. As you can see on the screen there, we've got Hello World SPI connectivity. I don't want to spend too much time on the GLCD commands today because that's not what it's about. It's around showing you that you can SPI works extremely simply through a number of simple constants. But I want to now that clear screen. If you can see that clear screen, I think that's quite important, because what I'm going to do now, I'm just going to comment out these two constants here. You only need to do, I'll just comment out one of them, which is hardware SPI. The moment I do that, the libraries will then switch to software SPI. And you will see that the clear screen as the examination is slower. That is because the frequency of the clock line is slower. The LGT chipset is extremely fast when it comes to the hardware SPI module. Let me just comment out these bits of code here, look. And we're going to look at this sprites demonstration, and then we're going to look at how the impact of the clock impacts that particular demonstration. compile it up, it's going to be using the hardware because the hardware SPI is defined, and you can see that that is extremely fast. Now I've got the screens inverted here, so I have to change my camera view. There we go. Now that is quite nice, it's quite smooth, but in reality, yeah, I had to put 100 millisecond delay in this code. Yeah, 100 milliseconds so that we could even see. Now I'm going to quickly compile it out and go out to the lab. It's just putting it into the chip for us. Those sprites are moving quite rapidly. That's because this chipset is specifically optimized for SPI. So what I'm going to do now is put the software on, and then we can, just by commenting out this one particular constant, which is hardware SPI, and you will see the impact of using software SPI. Just slower. It still operates the same, has the same capability, but it's slower. And the same applies if you want to use different modes of hardware. So you can tell Great Car Basic by setting this HWSPI mode to master fast. There are 4 options here: master slow, master fast, and master ultra fast. You can set it to a slower one, but it's still using the hardware SPI module within the LGT. It's still rapid, but the clock speed would be 1/2 the frequency of ultra fast. So we'll leave that as ultra fast, put that in, and we'll leave that running. And you can see that that is SPI is rather rapid on this chipset. If anybody was doing a new project, I would use LGT for the SPI alone. It's very rapid. So today I wanted to show you these 3 things, which is examine that setup, which is a simple set of constants. We put some simple screen just to prove it works as SPI in reality, and then show the sprites to show the difference in the frequency. So that was part 11, using SPI, extremely simple, set of constants, and it just works. Enjoy.